Okay, I'm gonna go through Unit 3 with the Unit 3 formula sheet and go over how to use the Unit 3 formula sheet and also how to use ChatGPT or another AI to be able to study for exam 3. So I'm gonna go ahead and share my screen and let's see here. Share screen 1, there we go. And so what I've got right here are prompts to get study questions. And this is all for Unit 3. The other thing that I'm going to open up is the Unit 3 formula sheet. So if you go to Home, we're going to go to Unit 3, and you can get the Unit 3 formula sheet right here, and you can download it and open it up. And so I'm going to open it up in, let's see here. uh, Show in folder. I'm going to open it up in, let's see, open with Chrome. There we go. So I've got the Unit 3 formula sheet, and yeah, so I'll put the Unit 3 formula sheet right over here, and then I will put everything else right there. So how do we use this? Now, I will say, what I would highly suggest is that when you're using the Unit 3 formula sheet, um, you uh, let's just go ahead and get into chat first, and then we'll go through exactly how to use the Unit 3 formula sheet. So prompts to get study questions. We're going to do two things with getting the study questions. We're going to put this first, these prompts in here. And so what I did is I made a prompt that has a topic right here: caffeinated beverages and energy drinks. And then all of these right here, all these questions are from my practice exam. And so I'm saying, hey, give me practice problems that are similar to the ones that are on the practice exam. So I copy all of this, Control C, and make it about caffeinated beverages and energy drinks. So I'm going to go to ChatGPT and I'm going to first add photos or videos. And I downloaded, if you looked at that announcement, it's got uh, this, um, what's that called? This decision tree that's attached to it as an attachment. And I'm gonna do that and then press enter, and it's going to give me a whole bunch of questions that go along with it. So looking at, because it's going to take a minute for it to come up with all the questions, um, looking at the formula sheet, I just kind of want to show you how it's broken down. We've got these sampling methods right here. And then right here, we've got the difference between a sampling distribution with the sample means and the population distribution. And then right here, probabilities with a Z or a T. So if I were you, I would go ahead and circle this, probabilities with a Z or a T score. The other thing that I would suggest that you do is there's another formula that's not actually written here. And the reason why is because it is the Z score for a single observation. And for a single observation, I'll show you why I don't have it written, is because it is on the Unit 2 formula sheet. So I'm going to show you the Unit 2 formula sheet. Okay. Unit 2 formula sheet with Excel. Okay. And you see the Z-score right here. Z is equal to the value of the individual observation minus the mean. So you can see it right here. Let's see here in this box. Gosh, I'm trying to highlight it, but in the bottom right-hand corner, there's the Z equals X minus mu over the standard deviation. So just notice that that's what the Z score is for that. And so it's just slightly different than the Z-score over here. Other than that, coming down on the formula sheet for 311, you'll see the decision tree at the bottom, and it's got the two left are margin of error for confidence interval around a mean, and then the center is the needed sample size for confidence interval around the mean, and the two right are dealing with the confidence interval around a proportion. And then the very last page, literally everything on this page is pretty much just the bottom chart that we have, the decision tree. It's literally the decision tree, but it's in a much larger, uh, easy to read format. Okay, so if you look at the decision tree from left to right, and if you already numbered them 1, 2, 3, 4, 5, you could come to the next page, and this would be one, this would be two, this would be three, four, and five, and you can feel free to write those. Okay, so I'm going to go ahead and go back to the chat GPT prompts. So it gave me some prompts, and we're going to go through these prompts and choose the right thing to do. So here's some fresh caffeine themed prompts that are similar to the structure that we gave. Okay, so now it says Campus Cafe surveys 150 students. 57 say that they have energy drinks today. You want a 95% confidence interval for the true proportion who had an energy drink. Okay, so I want to know what should I use in this formula sheet to solve for this very first question. And there's a keyword here. The keyword that I want you to look at is proportion. And so when we see proportion, we know right away that it's going to be one of two possible options because there's only two options, which are the bottom two, which is for the confidence interval around a proportion. Okay. And so I'm making a confidence interval around a proportion. Um, and now the question is am I needing a sample size or am I making an actual confidence interval? It says 150 students, 57 say that they had energy drinks. You want a 95% confidence interval for the true proportion. So they want an actual confidence interval. So it is the margin of error, which is step two, confidence interval around a proportion, then margin of error. So we're going to come down to the next page where it says confidence interval around a proportion. And what I'm going to do is I'm going to go to Excel, okay, and I'm going to go new, okay. I'm going to do it just like how you would do it on an exam. And I'm going to do, let's see here, uh, sample size, proportion, Z score, uh, MOE for margin of error, and then CI, upper, and then CI lower. Okay, and so let's come right over here. I'm going to minimize this, and we will fill in what it is that we need to fill in. Okay, so it says 150 students, so sample size is 150, and then the proportion is going to be equals 57 divided by 150. So that is the proportion. And then I want a 95% confidence interval around that. So for 95%, you can notice, which I do have it right here in the formula sheet for 90, 95, 99, it's going to be 1.96 for 95%. So 1.96. And then margin of error. Okay. Um, what is that margin of error for? We are going to calculate it with the z times like the formula that's on the formula sheet. So z times the square root of the proportion multiplied by 1 minus the proportion divided by n. So equals um, z multiplied by the square root of the proportion, okay, uh, multiplied by 1 minus the proportion divided by the sample size. Okay. And so that gives me my margin of error value, which is actually also in percentage form because we're dealing with percentage. Well, I mean, it's in technically, well, anyway. So the upper value and lower value. So we're going to do equals the proportion plus the margin of error value. Then we're going to do equals the proportion minus the margin of error value. And so I'm going to write this up like how to interpret. I am 95% confident that the true or actual population proportion of students who drink energy drinks is between 30.2% and 45.8%. Okay, and notice what I do here. I'm going to say I'm 95% confident of what the true population proportion, or the range of where that value is between this and this, and that's what you need to be looking for, the true or actual population proportion. Okay, so next we're going to go to number two. A nutrition lab measures caffeine in a random sample of 20 iced coffees. Okay, and so it's got the mean value right there and a sample standard deviation of 36 milligrams. You want a 90% confidence interval with the population mean caffeine per iced coffee. And so right here, we've got the mean, we've got a standard deviation, and we've got, hey, I want a interval around the population mean. So I'm going to go back up to right here. And because it says I want an interval around the population mean, we know that it's going to be a margin of error around the population mean, and it's either this one or this one, standard deviation, population standard deviation known, or population standard deviation unknown. And this right here, what you notice is it says S equals 36 milligrams. S is the symbol for sample standard deviation. So we're going to use population standard deviation unknown. Why? We don't have the population standard deviation. We have a standard deviation, but the standard deviation that we have is the sample standard deviation. So I'm going to come down to right here. Okay, which mind you, this box right up here at the very top is the exact same as the first two boxes. And yeah, so you can use the table at the top, or you can use this box right here, but I like using these boxes at the bottom personally, so I'm going to go ahead and do that. Okay. So I'm going to go ahead and put in there what it is that I need. Okay. So I'm going to put mean degrees of freedom. Uh, then I'm going to put T score. And then I'm going to put the standard error, MOE, and then CI upper, CI lower. Okay. So the other thing that I need is the standard deviation. And so we're going to do that as well. So what is the standard deviation? It's going to be 36. Okay, the mean, which is right here, is 178 milligrams. Okay, the degrees of freedom is going to be the sample size minus one. So it's 20 minus one, which is 19. Okay, and then t-score. How do we calculate the t-score? The t-score is right here, equals t dot inverse dot 2t, probability in degrees of freedom. So I'm going to do that. So equals t dot inverse dot 2t, probability is going to be uh so we want 90% confident. That means that we want to put zero point 0.1 because it's the complement to the 90% confident. And then degrees of freedom is going to be um 20 minus 1, which is 19. Okay, which I could have just pulled from above. And that gives me my t-score right there. So standard error um is going to be right here. So it's still standard deviation. Oh, actually, right here. Determine standard error, standard deviation divided by the square root of n. So equals standard deviation divided by the square root of the sample size. Oh, doesn't have the sample size. So we'll just go, sample size is 20. Um, and then yeah, so we got the standard error. And then the margin of error is going to be equals the t-score multiplied by the standard error, which it's gonna give you 13.91. And so now what we're going to do is we are going to make the upper and lower confidence interval. So equals the mean plus the margin of error, then equals the mean minus the margin of error. And so once again, we've got this right here. This is the confidence interval. And so I can copy and paste from right up here, and I'm going to just change it. So now I am 90% confident that the true or actual population mean of caffeine and an energy of caffeine in coffee in iced coffees is between 164.08 and 191.91. Okay, and yeah. Uh, so next, and the key there was, hey, we only have a sample standard deviation, and we're looking for a confidence interval around a mean. So next, we've got last semester, you were estimated that 42% of students consume caffeine after 6 p.m. with a margin of error of 6%. If you want the margin of error to be 4% at the same confidence, how many students should you sample next time? Okay, so let's take a look at this. Last semester, you estimated 42% of students. What this is right here, estimating 42% of students consume caffeine, that's a proportion. So we've got the proportion already, and then with a margin of error of 6%. Now we want the margin of error to change to 4% with the same confidence, which it doesn't give us the confidence. But how many students should we sample? So we're going to look right here, and we're going to say, okay, we're dealing with a proportion. And over here, it's needed sample size. Why? It says how many students do you need to sample. So we're going to go to needed sample size. And so I'm going to come down here and do, let's see here, uh, proportion, max, MOE, or let's just put Z and then sample size. Hold on 1 second. Okay, sorry, just had to step out for a second. So we're picking up on number three. We've got the proportion, the max margin of error, the Z, the sample size. I pulled it all from the this right here, the needed sample size. Um, and so we'll go ahead and uh, fill it all in. So the proportion is 42%. And then the max margin of error. So you notice it was 6%. So now it's going to be 0.04. And then the 42, we need to put as 0.42, not 42. And then for the z-score, it doesn't have a z-score actually because it doesn't have the confidence level. So I'm just going to, don't do this in the exam or anything because I'll actually give it to you. But I'm going to put it at 95%. So I'm going to put it at 1.96. And then the sample size I'm going to do equals the proportion multiplied by, close parentheses, 1 minus the proportion, okay, and then multiplied by the z-score in parentheses, divided by the max margin, or yeah, max allowable error, and then we're going to square it, which gives me a needed sample size of 584.88. Now, this is not the exact number that I want to sample. What I want to do is round up, and so I'm going to go up to 585 is the correct number. Okay. So next, I'm going to go to number four. Um, For a popular energy drink, the population standard deviation of caffeine is known to be 18 milligrams. A campus sample of 25 cans has a sample mean of 158 milligrams, build a 90% confidence interval for the population mean per can. Okay, so once again, I'm going to come over here and figure out where I need to go. There's some key words here. First of all, if you hear the word standard deviation, you hear the word mean, average, something to that effect, then you're dealing with either the mean, which is the bottom left-hand quarter, confidence interval around a mean, or you're dealing with probability. So over here for number four, I don't see anywhere in the question where it says anything about a probability, so I'm probably going to be dealing with a confidence interval, and he says 90% confidence or 90% interval for the population mean caffeine per can. So I'm going to be doing a 90% confidence interval. And so over here, confidence interval around a mean, it doesn't ask for a sample size at all. So it is going to be a margin of error around a mean. And if you look at the bottom left-hand corner, it's going to be the standard population standard deviation known. And the reason why is it has the symbol right here, lowercase sigma, of 18 milligrams. So it is population standard deviation known. So I'm going to come right down here, which is right here, the first one, the very first one. And so I'm going to fill that out. And so I'm right here. I'm going to do it says determine the mean point estimate. Literally all that I'm asking for is what's the sample mean? Okay. Uh, what's the z-score? What's the standard error? What's the margin of error? And then what's the CI upper, CI lower? And once again, formatting it like this is going to help you keep on track with it. So right here, we've got a sample, we've got a mean of 158 milligrams. So that right there is your point estimate of the population mean, which is just the exact same thing as saying, hey, I took a sample mean and I'm using it as the population mean and making a confidence interval around it. Okay. So then z-score for 90% is going to be 1.645. Which is also in the right here in the formula sheet, 1.645. Okay. And then the standard error is going to be equals. Um, so let's see here. The standard deviation right here divided by the square root of n. So the standard deviation is going to be 18 milligrams divided by the square root of the sample size. The sample size is 25. Okay, so it's going to be 3.6 is going to be the standard error. And then the margin of error is going to be equals the z-score, which is right here, multiplied by the standard error. Okay, so my margin of error is 5.922. Then I'm going to do equals the mean plus the margin of error. And then I'm going to do equals the mean minus the margin of error. So how do I interpret this? I'm going to go ahead and interpret this information. And so and just put this right here. I am 90% confident. Let's see here. Is it 90? Yep, 90% confident that the true or actual population mean of the caffeine, um, uh, let's see here, per can, uh, per can is between 163.922 and 152.078. Okay. Next, let's see here. Okay, so we're going to go into question number 5. Assume the population mean caffeine for a 16-ounce cold brew is got a population mean of 190 milligrams with a known population standard deviation of 40 milligrams. What's the probability of choosing a random sample of 30 cold brews with a sample mean of less than 100 or 180 milligrams or less? So I'm going to go back to the formula sheet, and there is a very particular word in here that in the question, and that is probability. So when we're dealing with probabilities, we're going to be dealing with something with this right-hand part of the formula sheet. So I'm dealing with probabilities, and more specifically, what's the probability of a sample of 30? So what's the probability of observing a sample with a particular value for its mean? So I'm going to put in all this information right here, just like what you guys would for the exam. So sample, pop, mean, standard deviation, sample size, degrees of freedom, sampling error, standard error, uh, z-score, uh, or t-score, probability below, probability above, whatever. So we'll do that. So What does it ask for? What's the probability? What's the probability that a random sample of 30 cold brews will be 180 or below? So we're only going to do below. So what's the sample mean? We've got the sample mean of 180, and the reason why is we come right down here and it says, what's the probability of getting a sample mean of 180 or less? So 180, population, right up here, 190. Okay, standard deviation, okay, is right here, which is 40. Sample size, okay, it says 30, n equals 30. Okay, degrees of freedom. I don't need to care about the degrees of freedom. Why? Because this is a population standard deviation. If it's a population standard deviation, I'm going to be using a z-score, not a t-score, so degrees of freedom doesn't matter. Then sampling error, which if you look right over here, how do you calculate sampling error? It's sample mean minus population mean. So equals sample mean minus population mean. And then standard error equals standard deviation divided by the square root of the sample size. Okay, z-score. Okay, what is the z-score? How do you calculate the z-score? You calculate the z-score by doing the sampling error divided by the standard error. So equals sampling error divided by standard error. Okay, and then how do you get the probability below? Equals norm dot s dot dist, and then I'm going to put the z-score, and you always put true. Okay, so what is the probability of getting a value below this z-score? The probability of randomly selecting a sample of 30 cold brews with a sample mean of 180 or less is 8.5%. Okay? So the probability of randomly getting this or less is 8.5%. So let's go ahead and go to number 6. Using the same standard deviation, what's the probability that a single randomly chosen cold brew is 180 milligrams or less? So doing the exact same thing, what's the probability of a single one? Remember what we talked about earlier was, hey, if you have a single observation, um, it's going to be slightly different. Okay, how is it going to be different? Well, the z-score is going to be calculated by dividing it by the standard deviation. So we're going to do the exact same thing, literally the exact same thing, except the sample size is going to be 1. Okay, so we've got the sample mean or the individual observation mean. Okay, individual observation value compared to the population mean. And then right here is the sample size. Standard deviation is still 40. And then instead of sampling error, this is called the difference score. And then instead of the standard error, we're going to just do the standard deviation. So which is the exact, it's still 40 divided by 1, or it's just the standard deviation. So we just use the standard deviation. And so now we're going to get the, so we'll put the standard deviation here. So what is the z-score? Okay, z-score is equals, or sorry, we'll just put x minus mean divided by standard deviation. So we're going to do equals sample mean, or sorry, individual value minus population mean. And we'll put this in parentheses. Don't forget the parentheses. And divided by standard deviation. Okay. So which is negative 0.25 is going to be the z-score. And so what's the probability of getting below that is 40.1%. So we're going to just copy and paste this. Why? Because we can. The probability of randomly selecting a single cold brew with a temp of 180 or less is 40.12%. or 1.3%. And notice the values are the exact same: 30 cold brews, 180 or less, 180 or less, 180 or less. But the probability of getting 30 or with that value or less, with a mean of that value or less, is 8.5%. Well, the probability of picking just one is 40.13%. Okay. So there's still quite a few questions, and unfortunately, I'm running out of time. So I'm gonna pick up the rest of these a little bit later. So we'll start with these, and I would encourage you guys to keep chugging along um, and trying to solve all of these. Uh, but like I said, when you're dealing with probabilities, you're going to be dealing with this section. When you're dealing with confidence intervals around a mean, you're dealing with this section, the bottom left section, and then just go down to the next page. When you're dealing with the confidence interval around the proportion, you're dealing with the right section. The other thing that you just remember on this next page, t dot inverse dot 2t, this is how you calculate the, uh, what's that called? The t-score for a confidence interval um, around a mean when the population standard deviation is not known. And the probability that you put there is going to be 1 minus whatever the confidence interval is, or the complement to the confidence interval. So if the confidence interval is 90, you put zero point 0.1. If the confidence interval is 95, you put 0.05. If the confidence interval is 0.99, you put 0.01. So I'll pick up the rest a little bit later. Yeah.